Hypotenuse is exactly 36 units, and the perimeter of the triangle is 120 units. Our goal is to find the exact area of the triangle. Now, many students immediately try to calculate the two unknown side lengths, but that actually isn't necessary. There's a much cleaner algebraic approach, so let's go through it step by step. Let's call the two legs of the right triangle A and B. First, we'll use the perimeter. The perimeter equals A plus B plus 36, and we're told that equals 120. Now, subtract 36 from both sides, and we get A plus B equals 84. Keep that result in mind because we'll use it several times. Next, since this is a right triangle, we can apply the Pythagorean Theorem, which tells us that the sum of the squares of the two legs equals the square of the hypotenuse. So, a squared plus b squared equals 36 squared. At this point, we know two important facts. First, a plus b equals 84. Second, a squared plus b squared equals 36 squared. Now let's think about the area. The area of a right triangle is 1/2 multiplied by the base, multiplied by the height. In our notation, that's 1/2 multiplied by A multiplied by B. Notice something interesting here. We don't actually need to know A and B individually. We only need the product A multiplied by B. So the question becomes, how do we find A multiplied by B? This is where a very useful algebra identity helps us. The identity says that A plus B whole squared equals A squared plus B squared plus 2 multiplied by A multiplied by B. The reason this identity is useful is that we already know the values of A plus B and A squared plus B squared. Now let's substitute those values. Since A plus B equals 84, the left side becomes 84 squared. Since A squared plus B squared equals 36 squared, the equation becomes 84 squared equals 36 squared plus 2, multiplied by A multiplied by B. Now let's isolate the 2 multiplied by A multiplied by B term. Subtract 36 squared from both sides, giving us 2 multiplied by A multiplied by B equals 84 squared minus 36 squared. At this point, you could calculate both squares separately, but there's a much faster method. We use the difference of squares identity, which tells us that one square minus another square factors into the sum multiplied by the difference. So, 84 squared minus 36 squared becomes the quantity. 84 plus 36 multiplied by the quantity 84 minus 36. Let's simplify each bracket. 84 plus 36 equals 120. 84 minus 36 equals 48. So now we have 2 multiplied by A multiplied by B equals 120 multiplied by 48. Now divide both sides by 2. Instead of dividing the entire product at the end, it's easier to divide the 48 by 2 first, giving us 24. So, A multiplied by B equals 120 multiplied by 24. Multiplying those together gives 2,880. We're almost finished. Remember, the area is 1/2 multiplied by A multiplied by B. So substitute our value of 2,880. The area equals 1/2 multiplied by 2,880. Dividing by 2 gives 1,440. Therefore, the exact area of the triangle is 1,440 square units. Notice how we found the area without ever calculating the individual side lengths. That's the power of combining geometry with a clever algebra identity. If this shortcut helped you understand the problem, Don't forget to like the video because it really supports the channel. Subscribe so you never miss future geometry puzzles. And leave a comment telling us whether you spotted this trick before we revealed it.